Hey, Chemsters, this is Mrs. Bailey bringing you the summary of everything we've been doing of Sn1, Sn2, E1, and E2. So if you want to go look for it, it should be in your practice packet. Find it, and when you're done, come on back. All right, I hope you found it. So this summarizes the entire chapter. So my hope is that you will have this handy when you're doing some of the entire chapter 6 practice that I'm assigning you next. So have this right in front of you and use it as a guide as you practice doing the substitution and elimination reactions, okay? So what about primaries? You'll see always your twos, never your ones. Here's the problem of secondaries. They're all sometimes. We talked about that in that last video, how you get all four of them if you have a secondary. And then you have to look at your other parts like your nucleophile or your temperatures and things like that. And then here's your tertiary. You have never and always. It's pretty cut and dry for your Sn1 and Sn2. Your E1s and E2s, like I tried to show you last time, is maybe a little bit more of a gray area. All right. For your nucleophile, hopefully this makes sense. Your Sn2, you're looking at your negative anion and your neutral nucleophile for Sn1. And then you're looking at big bulky ones. Why do they be bulky? Because they can't do substitution if they're not, if they are bulky. All right. They can't fit in to knock that leaving group out or something. All right. So you want the big bulky ones to be eliminated. Otherwise they can't fit in to do anything else. All right, temperature I've also alluded to quite a bit. 50 degrees seems to be that cutoff point, so room temperature would be included with your substitution. This is how I will tell you if I see plus heat, that means I want it hot enough to make elimination work, okay? So organic products, if you have an Sn2, because your nucleophile is negative, your organic product is neutral. Because in Sn1, your nucleophile is neutral, your organic product is a positive charge. But if you want to remove the H plus from there, you can, and then you can make it neutral, but that's an extra step, and we've already talked about that. Notice that your organic products are your double bonds in elimination. They're your alkenes. All right, so make sure you know that if it's elimination, you need to have a double bond someplace, okay? What about RNS or cis versus trans? All right, so you don't have to worry about it for primary. Rarely do you have to do it for tertiary unless it's such a large tertiary that each group off of the central carbon there is different. So maybe you have a methyl ethyl and a propyl group off of there. So you don't really come across it, but you can. So if it's cis versus trans, if it's secondary that has your three different groups, your hydrogen, and then like a methyl group and an ethyl group, we always switch them. And the same thing goes for Sn1. It will be a 50-50 mix if that comes in play. Okay, not every secondary is set up. If it's perfectly symmetrical, then you have to worry about it again. All right. But if it's not perfectly symmetrical, you have to worry about switching it up. All right. What about your eliminations? No, you don't have to worry about that at all. Okay. So for examples, all right, the only one I was able to fit in here was a primary Sn2. So here's my primary with a hydroxide. I swap it and then bromide, all right? Then I wrote C below, okay? I could not fit anything else in here. You might, but I can't. So what I did next was an Sn2 with a secondary. Notice how I have an A, B, C. It is not symmetrical. I have a 1 carbon group off of here and I have a 2 carbon group off of here. All right, so I do have to worry about this. So I made it a R2 bromobutane, okay, plus a strong base. And notice that this is an R, so this is an S. So I had to switch it. So the H is down below, I put it on up, and then I put the OH. Why? Because remember, it comes in from the back part of it, okay? The strong nucleophile approaches, or I'll put it over here, your strong nucleophile approaches your carbon from the back, pushing the bromine out, all right? So it had to come in from the back and to push it off. So this becomes an S, so it becomes S2 butanol. All right, so what about your E1? So here's your E1 with a tertiary Notice I have a weak nucleophile. All right, here's my positive organic product, but like I've told you, I don't know how many times, you can remove the H plus and then get a neutral one. So in this case, we have an ether, which you don't know how to name yet, so I didn't do that. So what about your Sn1 with a secondary? Again, this is a non-symmetrical one, right? So this is A, B, C. This is an R, 2-bromobutane. Notice what I get. I get an R, 1, 2, 3, and this is an X-methylbutane, all right? So it'd be 2X-methylbutane, or excuse me, methoxybutane, and then this would be your S, where I have, again, A, B, C going this direction. It's a 50-50 mix. I make them both. I guess it's not an either or, it's an and, isn't it? I'm sorry, I'll fix it right now. You get them both. You get 50-50 mix of those. And notice I already took off my H plus and my bromine already left, okay? So here's an example of an E2. It's a primary. Here's my big bulky nucleophile. Here's my heat. I get my double bond, and the H came off and went to my strong base, and then my bromide. Remember, it's a dehydrohalogenation. My hydrogen comes off and my bromine comes off. And then down here, let me get a little more, oh, a little too much. All right, so notice I have my primary or my tertiary with my weak heat. I get the same, I get a double bond. Notice that the H came off and jumped on my neutral there. There you go. All right, and there it is. Okay, so those are some examples for you to look at. Once again, your elimination has more variety, so you really got to be careful. This could be a strong nucleophile, all right, but maybe not quite as bulky. So things can be different when you're in college, but this is a general rule of thumb, okay? I hope this helped. We'll see you next time. Bye-bye.